All right, so let's see this particular question now. Largest subarray with zero sum, right? So in this question, we are given an array of integers and we are asked to find the length of the largest subarray whose elements sum to zero, right? So for example, if this is my input array, then we need to find the length of the largest subarray whose sum is equal to zero, right? So now over here, if you see from this particular index till this particular index, from -2 till 7, if you add all the numbers, you will get 0, right? And this will be actually the largest subarray with zero sum in this particular array, right? And hence my output will be basically the length of this particular subarray, which is 5, right? So my output over here will be 5, right? And in case if I'm not able to get any subarray with zero sum in this particular input array, then my output will be 0, right? That I don't have any such subarray, so the output will be 0 in that case, right? So that's what we need to do. Now maybe you can just pause this particular video and try to think of a solution, and once you are done, you can just come back and check the solution. Okay, so now to solve this particular question, we will use a hash map basically to store the prefix sums, right? And what is a prefix sum? A prefix sum is actually a cumulative total from the start of the array, right, up to the current element, right? So for example, if this is my current element and if I want to like calculate the prefix sum at this particular point till this particular element, it will basically be the cumulative sum of all the elements before this current element along with this particular element, right? So it will be 15 minus 2 plus 2, which will be 15 itself, right? So the prefix sum at this particular element will be 15. Now if I go to the next element, the prefix sum at this particular element would be 15 minus 2 plus 2 minus 8, right? So that would come out to be 7, right? So that means prefix sum at this particular element would be 7, right? So that's what we will be doing at every element, right? We will loop through this particular array and we will keep maintaining a running sum, right? Now, what we will also do is that after calculating this running sum or this prefix sum at every element, we will check if this same prefix sum, if we have seen this before, right? And this we can check using the hash map, basically where we are actually storing these prefix sums as in when we are seeing them, right? So now if I'm at this particular point and if I'm saying that the prefix sum that I've seen so far is 7, or the prefix sum at this particular element is 7, I will just look up my hash map for this 7 prefix sum, right? And if this prefix sum is already present in my hash map, it would mean that I have already seen this before, right? And that's where I can conclude that all the elements between these two indexes, basically the current index and the index where I have seen this prefix sum before, will actually cancel out each other and the sum of those all these elements will be 0, right? And that's why actually I'm getting a repeated sum, right? Because the elements in between these two indexes, including this current index, actually sum up to 0, right? So that's the conclusion. If I'm getting this prefix sum at any particular element, repeated, right? Or already present in the hash map, already seen before, right? And also we will just keep a track of the longest such subarray that we have seen so far by comparing its length, right, to our current maximum, right? So we will just keep maintaining a maximum length variable, right? And to begin with, we will just initialize it to 0. And then whenever we are encountering any such subarray whose sum is equal to 0 through the algorithm that we just discussed, we will just compare that current length with whatever we have currently in the maximum length variable, and whichever length is greater, we will just use that as the new value of the maximum length variable. That's what we will be doing, right, at every step. So now let's declare a hash map and we will be initializing it with some 0 at index -1, right? That's what we will be doing. And why we would be doing this? Because see, as per our algorithm, at every index, we have to see whether we have seen the prefix sum at that particular index before by looking it up in the hash map, right? Now consider a case where actually I'm getting the prefix sum only as 0 at that particular index, which would mean that all the elements before that particular element, right from the beginning, right from the first element, actually sum up to 0, right? But then as per my algorithm, I will only conclude that the current subarray has a sum 0 if I am able to see that prefix sum in my hash map. So to just like have this particular case caught by my algorithm, I will just make an entry of 0 as well in my hash map initially, and I will just assign the index as -1, right? So that it considers all the elements starting from 0 till that particular current element, right? So that's what we are doing now. And also we will initialize the maximum length as 0 to start with, right? And also we will start computing the running prefix sum, right? So that's what we are doing over here. Now what we will do is we will just loop over the array now and we will start calculating the prefix sum, right? So now at index 0, we encounter 15, right? So the prefix sum will now become 15 itself because we are at the first element. And since 15 is not there in our hash map currently, we will just add it with index equal to 0, right? Now when we move at index equal to 1, we add -2. So the prefix sum becomes 13 now, right? Again, it is not in the hash map. So we will store it with the index as 1, right? Now we move to the index equal to 2. We get 2 over here, right? So our sum will become 13 plus 2, that is equal to 15. And 15 is actually present in the hash map at index 0, right? And this would mean that subarray from 1, which is the next index, to 0, till the current index, which is 2. So subarray from 1 to 2 has a sum equal to 0, right? And obviously its length is equal to 2, right? Which is actually greater than the current value of the max length, which is actually 0 right now, right? Because we have initialized it to 0, right? So that means the new maximum length will actually now become equal to 2, right? So we will just reassign maximum length to 2, right? Now we will move to the next index, which is 3. Now we get -8, so the sum will become 7 now. Now 7 is again not in hash map, so we will store 7 in the hash map with the index equal to 3, right? Now we move to the next index, 4, right? We get 1, so the sum becomes 8 now. Again, it is not in the hash map, so we will store 8 in the hash map now with the index equal to 4, right? Now we move to index equal to 5, we get 7, sum becomes 15, right? 15 is again present in the hash map at index 0, right? So now again we can conclude that subarray from 1 till 5 has sum equal to 0, right? And now if you see, the length of this particular subarray is actually 5, right? Which is actually greater than the current value of my maximum length, and so I will reassign 5 to my maximum length variable now. So my maximum length will now become 5, right? And now I will move to the next index, which is 6. I get 10. My sum will become 15 plus 10, which is 25, right? Again, 25 is not present in the hash map, so I will store 25 in the hash map with the index equal to 6. Now again, I will move to the next index. I get 23, right? So my sum will become 25 plus 23, which is 48. 48 is not present in the hash map, and so again I will store 48 in my hash map with index equal to 7, right? And that's it. Now I have completed the loop. I will come out of the for loop, and whatever is the value of my maximum length at this particular point in time after coming out of the for loop, that is going to be my final output. That is going to be my final answer for the longest subarray with 0 sum, right? And in case if I was not able to find any subarray with 0 sum, I will be having 0 in my maximum length variable, and that's what I will be returning, right, as a default value, right? So this is the entire algorithm to find the longest subarray with 0 sum. I hope you understood it well. And now talking about the time and the space complexity. See, time complexity, we are just looping over this entire array once, right? So it is going to be order of n, it is going to be linear. And now talking about the space complexity, now since we are using an extra hash map over here to store the prefix sums at every index, it will be order of n, right? We are using order of n extra space over here, right? So the time and the space complexities both will be order of n over here, right? So that's the entire solution. Now maybe let's code this particular solution along. All right, so let's code this particular solution that we just discussed. So to start with, I will just declare a function called maxLength, right? And this will accept an input array, right? Like this. Now what I will do is I will just capture the length of this particular input array in a variable n, like this. And now I will just declare and initialize my hash map with 0 and -1, like this, right? Now I will just declare the maxLength variable and initialize it to 0, right? And also I will just declare and initialize my sum variable to 0, right? And this sum will basically be the running sum. It will be the prefix sum that we will be calculating at every index as we are looping through every element of the array, right? Now what I will do is I will actually loop over every element of the array. So I will loop through range n like this, right? And I will keep adding the current element like this to my sum variable, right? And then what I will do is I will first of all check if my sum or the prefix sum at this particular current index is not present in my hash map like this, right? If it is not present, I will just make an entry of this particular sum in my hash map with value as the current index like this, right? And if that's not the case, if sum is already present in the hash map, and it would mean that the subarray between these two elements, including this last current element also, actually constitutes a zero sum subarray, right? So I will just calculate the length of this particular subarray now, and I will just compare it with the maximum length variable, right? And whichever is greater, I will just reassign to my maximum length variable then, right? So what I can do is in the else part, now I will say max length is equal to max of current index minus hash of the prefix sum that I have calculated and the max length itself, right? Whichever is greater will get assigned to my max length, right? And finally, once I have looped over all the elements of this particular array, I will come out of this for loop, and finally I can just return my max length, right? Whatever is there in my max length variable, that is going to be my final output, right? So this is the entire code for the solution. And again, talking about the time complexity, since we are just looping over the entire array once, it is going to be order of n. And talking about the space complexity, we are just using an extra hash map over here, which in the worst case can be of size n. So again, the space complexity will be of order of n, right? So that's it. And now I will see you in the next question. Thank you.